This theorem is sort of a reverse. The perpendicular transversal theorem, it's the same theorem, it's just stated from that we learned the other day. It's just stated from a different perspective. So if you remember before, we had said that if M is perpendicular to N and if L is perpendicular to N, then these two are parallel. Well, that works if we know that these two are parallel, but the other part can be true as well. If we already know that these are parallel, and I know that M is, or if I know that L, let's say, so that if I know that L is perpendicular to N, then I can conclude that M is also perpendicular to N. It's just another perspective on the same theorem. So let's go ahead and try proving a relationship between two lines. Here we have four lines. We have line A, line B, line C, and line D. I can tell that C looks perpendicular to B. Also, D is perpendicular to B because I have the little right angle boxes there, and I have A that is also perpendicular to D because of that little right box. Let's go ahead and prove the relationship between two lines. So we're given that C is perpendicular to B. We are given that B is perpendicular to D, and D is perpendicular to A. I need to prove that line C is perpendicular to A. Here are my statements and my reasons. Number one, C is parallel to D. C parallel to D. I can say that because the theorem is two lines perpendicular to the same line must be parallel. And I can easily jump to the next conclusion to our proof. C is perpendicular to A. C is perpendicular to A. And I can say that because of perpendicular transversal theorem. C is perpendicular to A because of the perpendicular transversal theorem.